Solving equations. You have solved equations which have integers as solutions. The same methods are used to solve equations which have fractions as solutions. For example, negative 9x minus 6 equals 5. We called these two-step equations. And anytime we work with equations, remember, we always think opposite. And when we think opposite, it also applies to the equations in which the order we would handle these. We've got multiplication, we've got subtraction. Ordinarily, we'd always do the multiplication before the subtraction. However, since we're working with equations, we're thinking opposite. We're going to get rid of this negative 6 first. How? Add it to both sides. Go on over here, add the 6 here, leaves us with negative 9x is equal to 11. To get x by itself, I'll need to do what? Divide both sides by what kind of 9? X is equal to a negative 11 ninths. Fraction is the solution. It doesn't matter if it's improper. You don't have to put it into a mixed number if you don't want. Just leave it as is. Okay? Here, you try. 2x minus 5 is equal to a negative 4. So, Raven, what do we do first? Added 5 to both sides, so 2x then equals what? 1. Divide both sides by 2 to get x by itself, and x equals half. Okay? Orlia, Mark, good? Try another one along those same lines. Negative 4x plus 6 is equal to 9. Play a science fair board, that's about it. All right. Minus 6, negative 4x is equal to 3. Divide both sides by negative 4. So x equals negative 3 4. Okay? Right? Good? Okay. Now those are the easy ones. Okay? Expect fractions to be solutions. Not to say that these are impossible, but they're going to require just a little bit more work. Whoops, minus 35 equals 0. What do we notice right away? I've got an x squared, and I've got an x. Yeah, I've got no like terms where I can simplify, so now I'm back to general trinomial. After I check, first of all, for the first thing I always check is GCF. So, no, I don't. So I'm going to have to go 2x and x using factors of 35 that together are going to give me a 3. So I think 5 and 7, when I multiply the 5 times 2, I get what? So where do I want to put that 5? Over here, because I'm going to go outer, inner. And I want to put the 7 here. Now, it's just a matter of making sure that if I want a positive 3, that my 10 ends up being positive. So, am I going to put the plus sign here or the plus sign there? And this one will be negative. And then how are we sure, Raven? What do we do? How are we sure? Right, because with the FOIL, we're focusing on the outer and the inner. So when I go outer, 2x times a positive 5, I get the positive 10. The inner, the negative 7, equals what? A positive 3. Right? Okay? So you can always check it. You can always check it. You're going to go through a little bit of trial and error. That's okay. They recycle paper these days. You use a little bit more, and that's okay. Now, once you get here, what we'll then do is essentially think about it. You have to make this whole thing equal 0. What do the parentheses tell you what operation is happening? Parentheses jammed up right next to each other, multiplication. That means either this parenthesis has to equal 0 or this one has to equal 0, right? So what I'm going to do is I'm going to make these two separate equations equaling 0. 2x minus 7 equaling 0 and x plus 5 equaling 0. So here, Marlia, the first thing I'm going to do is add 7. So 2x is equal to 7. Divide both by 2, and x will equal 7 over 2. And here, do what? Subtract 5. X equals -5. So you've got a solution of x equals -5 and x equals 7 over 2. You have two solutions there. Any questions on that? What's the hardest part? The factoring again. But, it's one of those things that once you start doing, it doesn't really leave you. Or they don't expect it to leave you. Okay? So when you get to that situation, you got to break these down into two separate equations. You have two solutions for those. As you look at page 269, what numbers do you see that would fit the description of you have two different solutions? From 13 to 30. I see number 22, right? 23? Yeah. 24. What do we do with 24? Yeah, so we have the 6y squared plus 11y, and it equals -4. But I need it to equal 0, so I'm going to pull this -4 over to the other side by doing the opposite, which is adding. So this is essentially what you're doing, okay? 6y squared, good catch. Okay. What about 25? Yes. 26? 27? 28? 29? 30? Okay. Take a look at number 19. Let's look at 19 together. It's a different kind of problem that we got to work with. 4x plus 2 is equal to 6x minus 7. Now, the nice thing about working with equations is you can kind of move stuff around, and you can move anything you want as long as you do the opposite to it. Okay? So, let's take a look at this 4x. How am I going to move it from this side to that side? Subtract it. So now I have a -4x. So on this side, I have 2 is equal to 6x minus 7 minus 4x. Can I do any simplifying with any like terms on this side? How so? 6x and a -4x leaves me with 2x. So now here's what I got. 2, keep it over there for now. 2x and what kind of 7? Okay. Now what? Let's move this -7 by doing the opposite, which is adding it. So let's add that 7 to the 2, and we get follow me? Now we'll divide both sides by 2. and x equals 9 over 2. All we did was we just kind of kept moving stuff around until we cleared things up with like terms or whatnot. Okay. Let's try one of those. Let's try number 21. Try number 21. All right, where do we move first? Anyone have any suggestions? Yeah. Why would we want to move the 10t and not the 13? You could move either. What's the benefit of moving the 10 and not the 13? It's smaller, and I would avoid working with, right. So good. So let's get rid of the 10t over here. Let's subtract it from here, leaving us with 4 is equal to 13t plus 5 minus 10t. Any like terms over here, Raven? 13t and a negative 10t leaves me with 3t. So 4 is equal to 3t plus 5. Subtract 5 from 4 leaves us with yes? Or we forget the negative, or what happened? Okay, it doesn't seem like a whole lot of work, a lot of problems, but there's a couple on there that might, could possibly take you a couple minutes to do. So 269, 16, and 24 even. I think that works out to like 4 problems. Okay.